Hi, I'm Ryan Herr, and this talk is about Picasso and programming. In 1945, Picasso created a series of bulls where he started with a fairly realistic bull like you see on the left, and through a gradual, progressive process, he deconstructed the bull, abstracting it to its essence, to a simplified geometric form. So in 1945, Picasso did that. In 2010, an anonymous illustrator posted a meme on Tumblr and Reddit, how to draw an owl. Again, we see a transition between two states. Step one, draw some circles. Step two, draw the rest of the owl. So the interesting thing when we compare these two sets of images, well, they're moving in opposite directions, right? The owl is moving from simple to detailed, but the bull, Picasso's bulls, actually moved in the opposite direction. It went from more complex, more detailed, to simplified. And that's often what we want to do in software, right? We want to really simplify our software over time to reduce the complexity, to find the right abstractions. So much as Picasso was seeking the right abstraction for the essence of the bull, software developers and mathematicians are often seeking the right abstractions that are concise and elegant and simplified. And it's not easy, regardless of which direction we want to go, right? The meme is about the difficulty from going to simple to the detailed if you don't see all the step-by-step process in between. And it may be even more difficult to remove complexity like Picasso did. So regardless of which direction we want to go, how do we learn to do it? Sometimes we can feel stuck. So I'm wondering here, if we abstract Picasso's process of abstraction, could that help us get unstuck? Could we learn from him? Well, even Picasso got stuck sometimes. A few months before Picasso drew his bulls, he was stuck on a particular painting for weeks. He was making another World War II type of painting. It was a follow-up to his famous Guernica, shown here. This one was called Charnel House. And he was stuck on it. You can see up in the top left some faint pencil lines, really throughout some faint pencil lines, and especially in that top left, it's not all colored in. So he felt stuck, and a friend asked him, "What's going on?" And Picasso said, "I'm going very slowly because I don't want to ruin it. I don't want to ruin the initial freshness of my work." Have you ever felt like that? Whether you're working on software or something else, you're worried because you don't want to ruin it, and you're not sure how to move forward? Well, Picasso continued explaining to his friend. He said, "If it were possible, there would never be a finished canvas. If it were possible, I would leave it as it is while I began over and carried it to a more advanced state on another canvas. There would never be a finished canvas, but just the different states of a single painting which normally disappear in the course of work." So Picasso was struggling with this. If only it were possible. Well, it turns out that it is possible in another medium. And Picasso used a different medium for his bulls. And he didn't do just 2. He did 11 bulls. And he used the medium of printmaking, because each medium has different possibilities, sometimes called affordances. And in printmaking, one of the possibilities is the ability to make copies much more easily. But Picasso was actually exploring a specific type of printmaking which was new to him at the time, lithography. Because lithography enabled not just copies, but also changes. Because prior forms of printmaking, like etching in metal plates, you can make many copies, but you can imagine that etching in a metal plate, that's pretty permanent, right? And similarly with carving into a wood block for wood block prints. But lithography, you use an oily crayon on a limestone, and wherever that crayon was, then the ink transfers. It attaches to that. And it is possible to make changes. It's actually not necessarily as easy as you might think, but Picasso experimented with it, and it was possible to make changes. And so this medium enabled him to work in these progressive states and to save the changes along the way so that we could see that step-by-step process, his creative process, his process of abstraction. He worked in the studio of a man in France named Merlot, and Merlot and the other studio workers, they gave quotes about their memories of Picasso working on this process. Merlot said, "One day, Picasso started work on the famous bull. It was a superb, well-rounded bull. I thought myself that was that. But not at all. A second state and a third, still well-rounded, followed. And so it went on. But the bull was no longer the same. It began to get smaller, to lose weight. Picasso was taking away rather than adding to his composition. He was carving away slices of his bull at the same time. And after each change, we pulled a proof. He could see that we were puzzled. He made a joke but went on working, and then he produced another bull. And each time, less and less of the bull remained. He used to look at me and laugh. Look, he would say, we ought to give this bit to the butcher. The housewife could say, I want that piece or this one. In the end, the bull's head was like that of an ant. In the last proof, there remained only a few lines. I'd watched him work, reducing, always reducing. I still remember the first bull. I said to myself, what I don't understand is that he had ended up where maybe he should have started. But Picasso was seeking his own bull, and to achieve his one-line bull, he had gone in successive stages through all the other bulls. And when you look at that line, you cannot imagine how much work it involved. So that was what Merlot said about it. Here's what Picasso said about it. He said, a picture used to be a sum of additions. In my case, a picture is a sum of destructions. I do a picture, then I destroy it. And it would be very interesting to preserve these metamorphoses of a picture. Possibly one might then discover the path followed by the brain in materializing a dream. So when I thought about this captivating quote, I had some questions. One, is it true that there were more destructions than additions? Or how can we quantify that? How can we get a better understanding of that? Because really, how does it work? How does this process work? And so I had this idea of how we could use another medium to explore these changes between states, not just the 11 states, but the differences in between each one. And so I thought that I would do what could be analogous to a get diff, to have a color-coded representation of the changes between states. So here we see the 10th and 11th state, and then on the right, we see the black lines are the portions that were unchanged, red are the portions that were removed in the transition between states, and green are the lines that were added. And I didn't use the medium of computation first to do this. I actually used the medium of tracing paper. I simply printed out as a proof of concept, printed out these states here, and then traced over them. And it really was even this process of embodied thinking, right? Thinking with your hand and following the same path that Picasso followed. Obviously, when he's talking about the path followed by the brain in realizing a dream, that's a more metaphorical path. But I thought if I follow his literal path of his hand, maybe I would start to absorb that understanding. And so this was a great way to prototype. This medium was the most accessible, fastest way for me to prototype, but it would have been rather tedious to do this for all the states. And so I figured out how to do it computationally to outsource that work to my computer. So I'll show a demo in Jupyter Notebook. And I actually think because of the difficulty of switching screens, which I apologize for, I will save that for the end and go through my slides. So here are the diffs between all 11 states. So now there's not 11 images, there's 10 because there are 10 transitions in between the 11 images. And you can see by looking through these images that Picasso's process at first was additive. We see more green in this transition between state 1 and 2, where the bull bulks up and becomes monstrous in form. But then we see in the red exactly like Picasso used this metaphor of the butcher carving up pieces. We see him with these vast swaths of red carving up the bowl and continuing to reduce it and subtract and delete parts of the bowl until we're left with this very simplified schematic linear representation in the final transition. So I got really excited working with the tracing paper, working with code to calculate the differences between these images, but I wondered if I could go further. I came back to this idea about discovering the path followed by the brain and materializing a dream. And I thought about some work that Brett Victor did, where again he traces a path literally in his talk about inventing on principle. And he shows the example of a platform game like Mario. And Brett Victor says if you have a process in time and you want to see changes immediately, you have to map time to space. And so he puts all the changes in this onion skin sort of view that is a lot more than just 11 states, right? To see the fluid motion by mapping time to space, to really see the path that the Mario-like character takes in the platform game. And so I wondered if I could use the computational medium, or as Brett Victor calls it, the dynamic medium with magic ink, to go even further in understanding Picasso's process of abstraction. And just as understanding his process might help us to make software, making software could help us to understand Picasso. So I actually came up with this animated representation between states 9, 10, and 11 that is looping through here. And I took some artistic license because some of Picasso's decisions are lost to time. They're not encoded in the intermediate states to say what order did he make these changes in, right? But if I were to segment it out and make these changes line by line, then I can get a simulation of what it might have been like to sit shoulder by shoulder with Picasso and see him making these artistic decisions, these choices of how to simplify the bowl through the last two states. Let me walk you through it line by line. So he starts out by saying this complicated face that he's left with over here, let me get rid of almost all of that. I can just use this sort of leaf oval type of shape, but get rid of the horns and all the complexity in the face, and then I'll draw in some newer, simpler horns and just a single small line for the neck. Now, I want to, this front leg, it looks kind of funky there. There's a whole lot of structure there, and I can reduce that front leg to a single line. And you know what? With the other front leg, I can do that as well. I don't need two lines. I can use a single line, and now I have my two front legs, even simpler. And then now this whole complicated mess in the back where we have the tail and many lines for the hind legs, I can remove almost all of that. And this one curve, Picasso keeps this one curve, but he repurposes it. He's playing games, he's exploring puzzles with it. Previously, that curve was part of the hind leg. Now, he must have this idea that could instead be repurposed as the tail if he simply draws a little connecting line. And further on, now this bowl has already gotten simple, but how could he make it even more elegant and compressed for the final state? Well, he starts out by choosing to get rid of all the complexity in the body, that polygon. So remove all those interior lines. And also this diagonal line that is the underside of the bowl, it gets a little bit complicated there where it joins those two legs. You can redraw that line and make it simpler, and they all connect at a single point there. Then he actually changes his mind about the tail. Said that what he did before was a way to simplify it, but he's actually able to simplify it even further, and instead reuse part of that curve of the hind of the animal and simply extend it down, and then that becomes the tail. But it actually connects up to the same point that it was before. So he's playing these games of what are the different ways that I can connect the dots. Sometimes people use the metaphor of cave paintings, how ancient humanity had this compulsion to draw images on the walls of caves. Well, I also think that you could make a metaphor to ancient humanity's practice of looking up at the stars and seeing all the different images that you could make in the stars. And different cultures found different ways to connect the stars into constellations. There are so many possibilities. Picasso is exploring those possibilities here. He moves and simplifies the genitals there and completes that curve there. Now he is saying, I simplified the head a lot, but I can make it even smaller and simpler. I can do the head of an ant, like Merlot called it, just a simple single circle, almost a dot. And these horns, which if you saw the 11th state and you didn't have this context, you might think, why are these horns a funny shape? Why does that one go so much farther up than the other? Again, it's like the constellation, playing these games with these puzzles of how do you connect the dots. He's reusing the same dots that he was before, but the one horn goes up to the same point and the other one goes to the base of where the horns were before. And finally, now that he's simplified the head, one final step, this complex polygon in the front, he can remove that and make two lines that all come to a single point. So this is how we can simulate Picasso's creative process, even though we take some liberties here. We extrapolate. These are almost certainly wrong in the details. We don't know which order Picasso made his marks to add and subtract. But yet we're able to see possibilities that we weren't able to see before. So each medium has strengths and weaknesses. Each representation has strengths and weaknesses. For example, to see changes at a glance, we could use a different type of diff, where instead of using all the pixels in the image, like on the left, which this to me is a beautiful, fascinating image to look at, but it's awfully complex. It's hard to see what's going on. Instead, on the right, we could use a more geometric representation where we're using shapes instead of pixels, the silhouettes of those states of the bowl, or you could call them concave hulls if you'd like. So this representation, while we lose some details in what's going on in the bowl, and that could be a perceived disadvantage, the advantage is that this way of abstracting Picasso's abstraction process, we're able to gain some clarity in how that shape changed. So you make these trade-offs. I'd like to show another geometric representation, and again, I will show the Jupyter notebook at the very end. And the representation is what you see here at the very top of this triangle. So I'm going to come back and explain this. But this image that's at the top of the triangle, that was generated with code, with Python code, to say take the 10th state and then apply a line simplification algorithm to that 10th state called the Douglas-Puker algorithm, which removes points from the lines to simplify those lines. And by applying this mathematical algorithm, the Douglas-Puker line simplification algorithm, could we try to in some way move from the 10th state to something that approximates the 11th state? Now, this is wrong. That top image is not what the 11th state looks like. It could be interesting, but it's different. So it's not an accurate representation of that 11th state. But it's interesting to see why it's wrong. And to do that, I'm using here Scott McCloud's triangle of abstraction from his book Understanding Comics. So he says you can make a triangle that maps out the possibilities of visual abstraction, where in the lower left corner you start with resemblance, like this photo of the girl. And as you progress up along that axis, then you have pure abstraction, picture plane abstraction, where you're deconstructing into geometric forms that lose the resemblance to the original image and also even lose the semantic meaning. It's no longer a face, it's just lines and shapes and colors and polygons. Then there's another type of abstraction, which is along the bottom axis that moves from resemblance to meaning. This is iconic abstraction. Like you see, the face getting more cartoony, where a single circle and two dots in a line can represent a face. But that is iconic abstraction. It still is the meaning of the face. It's representing that. And the challenge here, if we map various renditions of the bulls onto Scott McCloud's triangle of abstraction, we see that, okay, we'll start with resemblance with this first state of the bull. Now, this is still abstracted. It still is some evocative lines, but it's the most realistic. It has the most resemblance, so we'll start there. If we move up towards picture plane abstraction, that's the Douglas Puker algorithm. That could be representative of pure abstraction. If we move along the bottom towards iconic abstraction that preserves the meaning but loses the resemblance, then the way to represent this form of abstraction could be taking a hand-drawn picture of a bull by an untrained person, not an artist, from Google's Quick Draw data set, where Google collected tens of thousands of drawings of different animals and different everyday objects, crowdsource this data set so that they could use it to train recurrent neural networks to generate new images. But again, that type of abstraction is a different type. And the trouble, the difficulty with trying to capture Picasso's style with his unique flavor of abstraction is that he is not really doing one or the other. He's splitting the difference. He's going his own way, his own path, and incorporating elements of both picture plane abstraction and iconic abstraction. Now I will flip over to the Jupyter Notebook to show you some ways that we can do this in code. So I will just pull this over to the other screen here. Okay, so to calculate the diffs that I was showing you earlier, I can simply use some code to read in those images, the state 10 and state 11, and I can show those. And the exciting thing about Jupyter Notebook is that it is it's a REPL, so I can see the results, the images inline right there when I execute the code, and I can work iteratively. So it's maybe not quite as easy as the tracing paper, but it still enables this rapid feedback loop of experimentation. And now to calculate the diff, I need not just shades of gray, but I need discrete values to represent where Picasso made those marks on the limestone for his lithography. So I can calculate the mask, and now these are the masks for state 10 and 11. And it's a little bit noisy, but that's okay. This is rapid experimentation. It's prototyping. And now to calculate the diff, I can simply use Boolean logic, set logic, where I can say that the unchanged portion of the image is wherever there is a pixel that is present in both A and B. The deleted portions are the pixels that are present in A and not B, the tilde character being an operator, bitwise operator to invert there. So again, unchanged A and B, deleted is A and not B, and then the opposite, added portions are not A and B. And now if I show the unchanged portion, we see again it's noisy, but we see this curve of the back, we see the legs. If I show the deleted portion, there you're seeing mostly those interior lines like we walked through, Picasso removing, and showing the added portions, These are, again with some noise, the new lines from that 11th and final state. And now if I want to color code it, I can simply define my colors, white, red, green, and black here. Then I will make an empty image here of white, which there's not, as expected, there's not a lot to look at here. It's just an empty white image. Now if I add red to the image, I'm simply saying, okay, use this as a mask, and whatever portions of the image should be deleted, set those equal to my red color. And now if I show it, I've added that layer as if I was working in Photoshop, but I'm doing it in code, and now I have the red portion here color-coded. Now I can add the green, and now it's starting to come together. I'm seeing these new lines, and finally if I add the black lines for where there was no difference, where there was not a change between states, then I have this final image here. And if I repeat this process, I can do this for all the transitions between states, imitating what I did in the very beginning with my tracing paper, but using the advantage of the computational medium to save me some work, especially on some of those earlier states where there's just a lot more there. It's more complex, right? Now if I can bring this, this line simplification notebook over. Now, if I use just a few lines of code for the Douglas Puker algorithm, then I'm actually able to use another feature of the Jupyter Notebook called interactive widgets, where I've defined this function called simplify that applies the Douglas Puker algorithm, and it takes two parameters, the image that you want to simplify, and then a parameter called tolerance that says how much do you want to simplify it by. And if I drag this slider, you can see that when I start to increase the tolerance, it's keeping the same fundamental shape, but simply, in a way, smoothing it out, in a way, making it more angular, really. And if I continue to extend that, then it gets more and more boxy, and in my opinion, kind of interesting here. Let's see if I can extend that. So now here's in between, and these are really higher values than would normally be intended for the line simplification because we've lost the original shape, the original line, but that's kind of the point for our artistic purpose here. And so if I take it all the way to the maximum value that I'd set for the maximum possible value of 150, then it gets to this line here, this simplified contour, which in some ways is getting closer, moving state 10 to something that gets closer to resembling state 11, because a lot of the complexity in the back was removed. We see some simplification of the head and horn, although obviously it is a different, more angular shape. And so this was a way to use math and code and iterate and explore in the REPL to simplify that bowl, but in a way that was more pure abstraction and does not fully capture Picasso's process. Again, it's not perfect, but even the mistakes are interesting. So I think about Picasso's famous quote about computers. And of course, he was speaking at a time when computers were big impersonal machines used to calculate missile trajectories for war, and sadly that often is still what computers are used for today. But they can also be used for more, right? And they can raise interesting questions. They don't just give answers, they do give questions like, how do I try to capture this unique flavor of abstraction that splits the difference between picture plane and iconic abstraction? I'm not sure yet how to do that, but by exploring in the medium of computation, it's enabled me to imagine some possibilities and to have an interesting journey along the way, getting new insights into how Picasso created his bowls. So at the beginning we said part of the motivating reason for this talk is that Picasso felt stuck, even like we sometimes feel stuck, whether you're working in art or in software or mathematics. Oftentimes he makes it look so easy. Great artists and geniuses, they make it look so easy, but even Picasso got stuck. And so if you feel stuck, if you feel creatively blocked, you can think about the process that Picasso used when he was able to save his variations, to explore where he was going, and work backwards. Don't feel like you have to jump all the way to the simplified version, but paradoxically, you may have to start with a more complex version and then pare away at it in order to get through your creative block to achieve the simplified vision that you had in mind all along. Thank you.